Welcome to this explainer. Right at this very moment, there is a literal invisible hurricane of data just swirling all around us. Today, we're going to dive right in and uncover that hidden digital infrastructure and break down the fundamental building blocks of modern connectivity.
Really think about it for a second. How does a simple text actually reach your friend? You tap send, and bam, it's instantly on their screen, maybe halfway across the globe. It feels like magic, right? But under the hood, it's this fiercely complex, highly structured physical and logical system routing packets of light and electricity in mere milliseconds. And that's exactly what we're breaking down today.
So here's our roadmap for today. We'll quickly cover 1. The basics of data communication. 2. Networking versus data communication. 3. Data transmission modes. 4. Classifying networks by geography. 5. Mediums, ownership, and access. And 6. The power of internetworking. Let's get into it.
All right, starting off with Section 1, the basics of data communication.
At its core, data communication is simply the process of transferring data between devices through some kind of transmission medium, like a fiber optic cable or a wireless signal. But for this to actually work, two absolutely non-negotiable things have to happen. First up, delivery. The data has to hit the exact correct destination, not the server sitting next to it. And second, accuracy. It has to arrive completely unaltered. Because, as we know, a single dropped bit can corrupt a file or totally crash a stream.
Okay, let's dive into this. There are basically 5 core components to any digital conversation. If you send a WhatsApp message, your phone is the sender, your friend's phone is the receiver, and the text itself is the message. The Wi-Fi network carrying it, that's a transmission medium. But the real unsung hero here is the protocol. These are the strict, invisible rules governing the whole conversation. It's kind of like a digital handshake that ensures both devices perfectly understand the syntax and the timing of the data.
Moving right along to Section 2, networking versus data communication. Now, you hear these terms thrown around interchangeably all the time, but they are actually entirely distinct concepts. Networking is the infrastructure itself. It's how devices are physically and logically linked together. Think of an entire college computer lab. It's like a massive highway system connecting cities. Data communication, on the other hand, is the actual traffic moving on those highways. So networking lays the roads and sets the speed limits, while data communication is the actual act of driving the cargo from point A to point B. Make sense?
Next up, Section 3, Data Transmission Modes.
So the direction that data flows is governed by 3 fundamental modes. First, we have simplex mode. This is a strict one-way street with zero feedback, like typing on a keyboard to your monitor. Second is half duplex. Here, data flows both ways, but they have to take turns. It's exactly like a walkie-talkie scenario where you literally have to say over and wait your turn. And third is full duplex, where data flows both ways simultaneously, just like a standard telephone call or your high-speed home internet connection. And this brilliantly illustrates how massive the difference in efficiency really is. In simplex, that channel is permanently dedicated to one direction. Half duplex uses the whole channel, sure, but it completely sacrifices time because of that required turn taking, time 1, then time 2. Full duplex, though, is the absolute gold standard for modern tech. It effectively splits the channel's capacity so that constant, simultaneous two-way communication can happen without any collisions at all.
All right, let's zoom out a bit for Section 4, classifying networks by geography.
We generally categorize networks by their physical footprint. At the micro level, you've got the LAN, or local area network. This covers up to about a kilometer. Think your home Wi-Fi or the Ethernet in an office building. Scale that up to an entire city, roughly 5 to 50 kilometers, and you hit the MAN, or Metropolitan Area Network, which links multiple LANs together. Then, if you go way beyond that, spanning whole countries or even crossing oceans, you get the WAN, the Wide Area Network. Let's move to see how this builds, because it really is all about geographic scaling. Local networks aggregate into metropolitan networks, and then those metropolitan hubs ping data across continents, forming this globally intertwined wide area network. It's honestly like a massive, nested digital Russian doll, scaling literally from a single router sitting in your living room all the way up to satellites in orbit. Pretty wild.
Moving into Section 5, mediums, ownership, and access.
Now, the actual physical medium being used matters a ton. Wired networks rely on physical copper or fiber optic cables. These are the heavy lifters of the network world. They offer blistering speeds, top-tier reliability, and really minimal interference. Wireless networks, on the flip side, use radio waves or microwaves, which gives us incredible mobility. But, that mobility definitely comes with a trade-off. They're generally a bit slower and way more susceptible to interference. I mean, we've all had our Wi-Fi drop just because someone turned on a microwave or there's a thick concrete wall in the way.
And then, of course, there's the issue of access. Private networks are closed ecosystems locked securely behind firewalls, like a bank's internal servers. Public networks, like the Wi-Fi at a coffee shop, are open to everyone, but as we know, they are inherently risky. The really brilliant workaround here is the VPN, or Virtual Private Network. A VPN uses the dangerous, open roads of public infrastructure, but it wraps your data up in a highly secure, encrypted tunnel. It basically allows you to behave completely privately while standing right in the middle of a public digital space.
Finally, zooming all the way out for Section 6, the power of internetworking. So the crucial point is that internetworking is really the ultimate culmination of all these building blocks we've been talking about. It's the practice of taking multiple completely independent networks, which might be running on totally different architectures, and actually linking them together. By using sophisticated hardware like routers and gateways, which essentially act like universal translators, it stitches those isolated LANs, MANs, and WANs together so they can function as one seamless colossal system.
Now, what's really interesting here is how it perfectly visualizes this nested structure of global trust. Right at the core is the intranet, a strictly internal, private network for employees. Step out just one layer, and you have the extranet, where a company might securely link up with trusted external vendors. Step out one final time into the wild, and boom, you hit the internet. It's the grandest example of internetworking out there, where literally billions of disparate devices seamlessly connect in a massive public web.
Well, we've traced the whole journey, right from the simple sender-receiver components of a single text message all the way up to a globally interwoven web of submarine cables and encrypted tunnels. But here's a thought to leave you with. As internetworking continues to absorb millions of new devices every single day, from smart cars to fully automated cities, where do the boundaries of our digital infrastructure truly end? Thank you so much for joining me on this explainer today. Keep learning, and I'll catch you on the next one.